Differentiate the function f of x equals negative 2x squared plus 6x using first principles. So to calculate the derivative f dashed of x using first principles, we know that it's given by the limit as h approaches 0 of f of x plus h, so the function evaluated at x plus h, minus f of x, which is just the function, all divided by h. Therefore, the derivative for this question is equal to the limit as h approaches 0, and we need to include that on every new line of working. And then the limit is of f of x plus h, so into the function we substitute x plus h wherever there was an x. So this is going to give minus 2x plus h all squared plus 6 times x plus h. And then we're going to subtract away just f of x, which is minus 2x squared plus 6x. And make sure this subtraction has a bracket around it so you know to distribute the negative through the whole lot. Then all of that is going to be divided by h. So on our next line of working, we'll find that f dashed of x is equal to the limit as h approaches 0. And now we have to expand out this x plus h all squared, so we're going to have minus 2, and then it's going to give x squared plus 2xh plus h squared, plus, and then we expand out the 6x plus 6h, and then we're going to subtract negative 2x squared, so that's going to be positive 2x squared, and then we're going to subtract 6x. And once again, all of that is divided by h. Next, we're going to find that f dashed of x is equal to the limit as h approaches 0, and expanding this minus 2 through the bracket will give minus 2x squared minus 4xh minus 2h squared plus 6x plus 6h plus 2x squared minus 6x, all still divided by h. Now at this expanded point, you should note that everything that doesn't involve a h as a factor will cancel. So this minus 2x squared will cancel with the positive 2x squared, and this plus 6x will cancel with this negative 6x. Therefore, f dashed of x, the derivative, is equal to the limit as h approaches 0. And now as h is in every one of these terms in the numerator, we can take it out as a common factor. So it's going to be h multiplied by minus 4x minus 2h plus 6. And all of that is still divided by h. So we can now cancel off the common factor of h on the top and the bottom line. And because h only approaches 0 rather than equaling 0, we can do that step of mathematics. Therefore, our derivative f dashed of x is equal to the limit as h approaches 0 of minus 4x minus 2h plus 6. And now to evaluate this limit, it's sufficient to know that we can just substitute h in as being 0. So when we do that, we find that this is equal to minus 4x plus 6. Therefore, the derivative f dashed of x is equal to minus 4x plus 6 for this question.